You are able to see the slide and I am audible?
Yes, sir.
Yes, sir.
Both are okay.
Okay. So good afternoon to you all. So this session of prototype validation and converting prototype to a startup in IPv6, I'm going to discuss about basically in different sections. One will be the IPv6 preliminary I will be able to touch upon, and another one is what are the drivers for IPv6 migration, security aspect of IPv6, and also I'm going to discuss about prototype startup in IPv6. That is the main. And at the end, I'm also going to discuss about the NIXI IPv6 government
मेल में
of
आया मतलब
yeah.
मेल में आया B4BWU4.
Kindly unmute others. Kindly unmute others. And at the end, I'm going to discuss about NIXI IPv6 course, that is Ministry of Information Technology. They are also conducting IPv6 course and certification free for the students. That also I am going to discuss. So coming to the slide, first we'll discuss about the global internet management. Means how the internet is managed globally. As we know very well, if we require a internet connection, what is the most important thing is required? That is a public IP. Without public IP, you cannot have the connectivity of internet. So earlier we used to have IPv4. Now we have now IPv4 is going to be migrated in IPv6. That will in the detail I will be discussing these points. So IPv4 is basically conceptualized in 1991 and it's a 32-bit addressing system. That time it was thought that 32-bit will be the sufficient for connecting the devices available all over the different parts of the world. But nowadays we have seen the era of IoT, the internet over things, that devices are more devices is to be connected. So IPv4 has already exhausted in 19 that is already exhausted in 2011, and government of India has already issued the circular notification that if you are going to purchase any devices after 2020 onwards, it should be IPv6 compliance. So these details we will be discussing in the coming slides. So coming to the global internet management, how the internet is globally managed. On the top, who are the people, who are the organization? In fact, they are managing the internet. So the organization and the several organizations forms a framework for global internet governance. That is, one is IANA. IANA is the top body of the internet, that is called Internet Assigned Number Authority. And under this IANA, 5 RIRs are there. RIRs means regional internet registry are there, that you can find in the world picture. You can see one is Erin, second one is LACNIC, third one Afrinic, and this is Ripe. That is Ripenik is there. One more you will find Apnic, which this our area belongs. So ARNIC is nothing but American Registry of Internet, that is used for North America, and LACNIC is for the Latin America or the Caribbean countries. LACNIC is the organization that managing internet. So, and Afrinic, that is for Africa, and APNIC, this is our Asia Pacific, and another one is RIPE NCC, that is for European countries. So we can see the whole world is internet is managed by this 5 RIR registry, and top body of the internet is called INA. So the role of RIR. So what is the role of RIR, the regional internet that is registry? What I said earlier, that is IPv6 address allocation, the address allocation of that area is done by regional RIR one only. Uh, other region RIR cannot allocate the IP addresses of some other regions. That is, the management and deployment measurement is done by RIR. The research, education, and information distribution about IPv6 whole part will be covered under the RIR. Community outreach and listening, as well as representation in the forum such as ITU, OECD, the Internet Governance Forum, that is IGF, and ICANN. What is OECD? OECD, the Organization for Economic Cooperation and Development. It is the organization of 30 countries. And ICANN is this is ICANN means Internet Cooperation for the assigned name and numbers, assigned name and numbers. So, so this is the hierarchy. What I was trying to explain you in the earlier slide. In the nutshell, the whole hierarchy is given here itself. That is, what is the hierarchy of global address? As I say, top top level is INA. INA is Internet Assigned Number Authority, is called INA, and under this you will find Afrinic, Arnic, Apnic, Lacnic, and RIPE-NCC that I have already discussed the reason covered under this. So under this ethnic, you will find NIR. What is NIR? Is a National Internet Registers. National Internet Register, under which you will find ISP provider and further it will be connected to the end users. And another one is LIR, is local internet registers. I hope this hierarchy will be clear to all. So here I am going to discuss, as I said earlier, this is IPv4 and IPv6. What is the difference basically between IPv4 and IPv6? The basic, I said earlier, it has been conceptualized somewhere in 1981, and it is a 32-bit IP addresses, and maximum IP addresses that we can generate is 4.3 billion addresses could be generated using IPv4. But in case of IPv6, that has been deployed from 1998 onwards. Now it has gaining pace, and Government of India as well as our top body, America OMB, has already decided that that the whole IPv6 to IPv4 migration has to be completed on and before 2025. 25 it has to come. So once America is only single stack IPv6, in such scenario, world order has to be changed. So everybody has to at least convert.
এক্সকিউজ মি স্যার বলছি
Yeah, yeah.
স্যার আমার একটা বন্ধু স্যার রাহুল যে জয়েন করতে যেতে পারছে না স্যার আক্স টু জয়েন দেখাচ্ছে
You are not able to hear me, please. Hello. Hello.
Yeah, hello sir. Yeah, I am able to hear you, sir.
Yeah. Somebody kindly unmute others. Kindly unmute others.
Okay, sir. You continue yourself, sir.
Unmute others. So what I said, that is IPv4. The basic is, if any problem, if you are not able to hear, kindly let me know. So kindly unmute others, so it will be the discussion will be a smooth itself. So as I said, it's a IPv4 is a 32-bit IP addresses. So total 4.3 billion addresses can be generated up to 32-bit IP addresses. But IPv6 is a 128-bit IP addresses. With that, we can generate up to 7.9 into 10 to the power 28 IP addresses could be generated using IPv6. So what is so this IPv6? So it is said that through IPv6 this deployment policy, we can allot all living body in the world, that IP addresses could be allotted to all. Even one person, we could allot more than 1,000 IP addresses. So total IP addresses in case of 128-bit, that is called 3.4 undecillion. Undecillion is nothing but bottom you can see this is trillion, trillion, trillion. So many IP addresses could be generated using IPv6. So main advantage of IPv6 is that if you have so much IP addresses, so all the communication will be point to point communication only. So the point to point communication has inherent advantage that security agency can monitor you online. But in case of IPv4, we know we are running out of IP addresses. For that, we are using to increase the life of IP addresses. We are using that is NAT, subnet, supernet, CIDR. These all policy. So behind the net, many private IP addresses are there. So private IP addresses are mapped over public IP addresses through proxy. That is the main security concern in IPv4. But IPv6, that part is taken care of. And one more thing in IPv6, that is security protocols. That is IPsec is already IPsec is already inbuilt in case of IPv6, but in case of IPv4, we have to add on in case of IPv4. So in security part also, IPv6 is superior to IPv4. The IPv4 is a 4-octet, that is by numeric dot decimal notation can be designated, and IPv6 is a alphanumeric hexadecimal notation. Here we have 4-octet. In case of IPv6, we have 8 octets, and IP allocation in IPv4 that could be done by a manual configuration, a static configuration, that is dynamic or DHCP configuration can be used for IPv6, IPv4. But IPv6, the most important feature of IPv6 is auto configuration. Auto configuration in the sense plug and play. Network devices, the router, the switches can be connected as we are now connecting pen drive, we are connecting mouse, and immediate it starts functioning. So the auto configuration is the silent feature of IPv6, in that the network devices like switches, routers could be configured, could be plugged in, and the IP addresses could be automatically assigned to that. So the IPv4 addresses are running out. As I said earlier, Government of India has already passed the resolution that nobody in new IP pool will be allotted in case of IPv4. If you have IPv4 at present, so you can utilize those IPv4. You can increase the life of IPv4 by using NATing, CIDR, NAT, subnetting, supernetting. These are the techniques to increase the life of IPv4. But the day has come. It has to be totally migrated to IPv6. At present, we are using IPv4 and IPv6. We have IPv4 and IPv6 parallelly. We are using it, but the time will come. We have to switch off the IPv4 and we have to work with the IPv6. So coming to the IPv6 part, so address similar to the IPv4 that we have seen 4 octets. Now here we can find out it will be 8 octets. But in IPv6, addresses identify interfaces, not nodes. So interfaces, the router have a different interfaces. That interfaces will be identified in IPv6. It is a hierarchical topological addresses, forwarding based on best match. Some extra flexibility is provided in IPv6 that I discussed earlier also. That is anycast and auto configuration. Generally communication, you will find there are three techniques. One is unicast, multicast, and broadcast. But in case of the IPv6, there is no broadcast. Broadcast is managed by the anycast. But multicasting is there, where the message could be sent to a set of group. And auto configuration is the one of the main advantage of IPv6. Through that, we can use plug and play network devices that will be automatically a configuration using Slack or UI64 that we'll see in the latter discussion. And in IPv6, we have local node and link addresses available. Easier address change support systems are available in IPv6. The IPv6, it is, I said earlier, it's a 128-bit and it represents 8 octet, and each octet of 16-bit. We'll see further in the slide how it is 16-bit pieces in the hexadecimal that is supported by colon. So in IPv4, single dot is there, but if you will see IPv6, you will find double colon. So prefixes are IPv6 address oblique length, and the multiple 16-bit zeros can be compacted by using double colon. If two octets, we have continuous two octet, if we have 0, that can be compacted with a single octet by using double colon. We can see, we'll find in the latter also in our notation. So compaction only used once per address. So lower address 32-bit can use V4 format, that is DDD and D. So as I said earlier, that is IPv4. The unspecified address is all zeros, and in case of IPv6 is that is you'll find all colon. Loopback address 127.0.0.1, and IPv6 it will be designated by double colon 1. And IPv4 you will find private IP addresses. In each section you will find private IP addresses, class A, class B, and class C. That is 10.0.0.0 in class A, and 172.16.0.0 and 192 series .68.0. That is used for class A, class B, and class C. As I said earlier, private IP addresses are those IP addresses, private IP addresses are those IP addresses that can be reused at the different location. And in IPv6, you will find FE80:64, site local, FEC0, multicast, FE://8 will be designated. So coming to the IPv6 address, what I said earlier, it has a 8 octets. You can see on the top, 2610 is 1 octet, 00F80 is 1 octet. Like that, it has 8 octets. So 8 octets, so that bifurcation designation is like that. The first octet will be 2000://3. Means IPv6 addresses will start from the 2000 itself. Always, if you see the IPv6 address, that will start by 2003. And INA allocation to the registry, that is second octet. What I have said, this INA is a top body of the global internet management. Under that, 5 RIRs are there. So under this RIR, you will find ISP location. Third one is ISP location. Under this ISP location, fourth one is in-site allocation, subnet assignment, and last 2 octets. These 2 octets are used for interface ID. So these are the distribution of all the octets that is required to be known about this regarding IPv6. So as I said earlier, there are 4 types of IP addresses. Everybody knows that is one is public IP and private IP. That is in case of IPv4, public IP are the global IP addresses that can be assigned uh, at one person at any point of time. One IP cannot be global IP addresses cannot be assigned to a 2 person. So the private IP addresses, as I said earlier, this is private IP addresses can be reused at the different location. And one is static IP addresses, that lease line means as and every time if you log in, you will get the same IP addresses. In such scenario, we have called the static IP addresses. And another type of IP addresses is dynamic IP addresses. Dynamic IP addresses in the yes, please. Anybody?
No, sir, nothing.
Okay, no issue. No issue. Dynamic IP addresses are IP addresses that are allotted dynamically, like modem. If you are switching off your modem, your IP will be taken back by the system. That is called RAS, Remote Access Server. So dynamic this composition is like that. In our area, if we have 2000 internet connection to a particular ISP, so that is not necessary to have a 2000 IP addresses. So 60% or 70% IP addresses is enough. If we have 2000, if we have 1400 IP addresses, that is sufficient to allocate all the users. That is what is the defined here is, it is presumed that all connections will not be through at the same time. 100% utility will not be there. So by using, why? Because IP addresses is very costly nowadays. So to optimizing that dynamic IP addresses, we use it as and when somebody is using connecting, IP addresses will be allotted. If not using, that will be withdrawn from the system, and some other users can be assigned. That is dynamic IP address. This is very well known that IPv4 classes of network. We have class A, class B, class C. Class A having one network and 3 hosts, whereas class B we have 2 network, 2 hosts, and class C a 3 network and three network and 1 host is class C. Class D 224 series is a multicast, and class E is used for research purposes. Though it has a IP addresses series also from 0 to 127 is class A, 128 to 191 is class B, 192 to 223 is class C, 224 to 39 is this is class 4, and further it is used for research purposes. So that is everybody known. But in case of IPv6, there is no classes. Why? Because ample IP addresses are available. There is no necessary for bifurcating in the class. In the IPv6, we can have a point-to-point connection. As I said earlier also. So every human being can be allotted more than 1000 IP. So future connectivity, what is thought? Uh, hello, hello. Kindly unmute. Kindly unmute. Hello. I'm audible to all.
Yes, sir.
Yes,
Okay,
sir.
okay,
Yes,
okay,
sir.
okay. No issue, no issue. Some noise was coming. No issue, no issue. Kindly unmute others. So there will be no hindrance at all. So what I was telling, that in IPv6, more than 1000 IP addresses can be allocated to a single living body. So it is thought that it is conceptualized that in this is the IoT era, and IPv6 that is 5G is coming. So it is thought that that up to 225 there will be 30 billion connections, and current world population is 7.5 billion. Current world population is there. Means from up to 2025, each individual will be connected with the 5 devices. Maybe one maybe your computer, one maybe your this is mobile, maybe another IoT devices will be connected. Maybe your car may be connected. Maybe other things will be connected. It is thought that every person will be connected with the 5 devices, and that is not possible with the IPv4. We cannot think of, our world population is 7.5 billion, and IPv4 we have max to max 4.3 billion IP addresses. So coming to the IPv4, and IPv6, main difference in the header format of IPv6, IPv4. In IPv4, some are kept as it is only, another are relocated, and third one, some are relocated, and some new concepts are also added in the IPv4. So we can see here in the picture, you can see here this yellow field name kept for the IPv4. It is kept IPv4, and this brown or red, you can say brown, that is not kept in IPv6. Positions are changed and new fields are included. What are the things that is kept? Is one is version, source address, and destination address. These 3 fields only kept intact, and other one is that is relocated. That is type of service. You can see this is the type of service. Type of service is changed to the traffic class. As you know very well, the type of service in IPv4 used for traffic engineering, TOS, traffic engineering. How? Why? Because the data, the packets, how you will prioritize the packets? Using traffic engineering only. So that traffic engineering, the type of service field is changed to the traffic class in IPv6. And TTL, time to leave is changed to the hop count. You know very well, if a packet is generated through a source, it will have a 255 stamp. So when it will go to the one hop, it will be reduced to the 254, 253. So it will have a life up to the one only. When the TTL is come to the 0, so it will be discarded. Why it is done? Why? Because if any packets is not reached to the destination, it is misplaced, not received, so it will be keep on roaming in the network. The congestion will increase. So to avoid the congestion, TTL is used. So the same field has been kept in IPv6. That is hop limit that is there, and protocol is changed to the next header, and the new concept, that is flow level, is added in IPv6. So we can see here these are the field field that is relocated. We can find these are the field that is relocated. So total length is changed to the payload length. Coming to the next, type of service is changed to a traffic class. I said earlier, it is a very important parameter, that is TOS, and that is used for TOS, that is used for traffic engineering. Next is time to leave is changed to the hop count, and protocol is changed to the next header. So next header is a very crucial concept in IPv6. It also reduces the header length. So here processing is done hop by hop only in this IPv6. So this is the comparison between IPv4 header to IPv6 header. So in a nutshell, I said some of the field are kept as it is, some are relocated, some are deleted. If you can see this red one, IHL, identification flag, flag offset, header checksum, option, padding, these fields are not available in case of IPv6. So this is the format. You can see the IPv6 address format. This is 128 bit. That is, I said, 16 bytes, and that is there. So this is, you can say, this is one octet. 0, 1, 2, 3. It forms the one octet, and this one octet is a 16 bit. 0 will be represented by 000. eh? 1 will be represented by 001. Like that, it will be a 128 bit. So its structure is that, like that. So registry, which I have seen earlier, ICANN RIR registry will have /23 addressing. ISP prefix will be /32. Site prefix will be /48, and subnet prefix will be /64. And last two octets are used for interface ID, that is called global IP addresses, GUA, GUA, global unicast addressing, that is 2 octets are used. So this is the same format has been seen. The routing prefix, here it is there, FE0, FC0, that is for different purposes. It has been shown. So this is the differences. I have discussed all those differences in the earlier slides also. We can skip this one. But here we can see the multicast in IPv4 is 224.0.0./4. But in case of IPv6, the multicast is taken care by FF00::/8. Broadcast is IPv4, but in IPv6 you will not find broadcast. Only any cast is there. In IPv6 you will find any cast. This is the structure of IPv6 addresses, what we have seen in the earlier slides. One is unicast. Unicast is public IP addresses in IPv4. It's called unicast addresses in IPv6. Multicast, that IP addresses for the selected group, and any cast, that is for the particular interfaces only. So if you will see the multicast, there is well-known port FF00::/22 ports. Well-known ports are there, and these are the transient ports. FF10::/12 that is used, and this is solicited node address. So in IPv6, the solicitation is done. Suppose a PC will send the masses to the network that any router is connected. If router is connected, this router solicitation will be sent to the that particular PCs, and with that router solicitation and their IP addresses will be formed. That we will be seeing it, and in IPv6 you will find global unicast addresses that I said, that is equivalent to the public IP addresses in IPv4. Link local address, that we call it LAN. That LAN could be designated by FE80. So if any devices is plugged in, first FE80 local IP will be allotted to them. Then further router solicitation and everything is there. So using Slack, IP addresses is allocated. So loopback address is : :1, unspecified is all colons, and you can see this is unique local and embedded IPv4. So that is IPv4, that is allocation, how it is done, that is manual and dynamic. This is configuration of global unicast addresses or automatic. This is global unicast address, that is also called AGUA. So this is manual. In manual you will find a static, and one is a static plus UI64 mechanism is there. Through that IP addresses is allocated to the devices, and another one is dynamic, stateless, and stateful. Stateless is Slack. Stateless could be done using Slack, Slack and Slack plus DHCP-v6 IP addresses could be allotted. This is the same what we have seen earlier in the slide. This is the 48 bits. That is the 48 bits that covering this prefix assigned, that is INA number, and top level ISP, that is 48 bits, and subnet ID is 16 bit. As I said, 64 is used for interface ID, that is for global IP addresses. This is IPv4 and IPv6 we have discussed sufficiently. In IPv4, this is the network portion and host portion. Here, this is host portion is /64. So this is the method of IPv6 address configuration. How, as I said earlier, IPv6 is auto configuration is the one of the important aspect of IPv6. Means plug and play. The router, the switches, we can just plug in. The IP addresses will be allocated to the routers. Routing table will be generated automatically. It will capture the data of the neighboring, and all the routing table and lookup table will be automatically created in case of IPv6. How it is done, we can see it. So this is address configuration. Address configuration is done by global unicast addresses, GUA, and local link address. These two are combined, and most common of IPv6 unicast addresses as an interface. So multiple IP addresses can be configured on one interface. So here one interface may have multiple IP addresses. Once IP address is configured, then it will not be a permanent. It will check for DAD. There is any duplicate. If there is duplicate IP addresses, that IP address will be dropped. So DAD is similar to the greatest ARP in IPv4. We know ARP, RARP. If we know the IP address, we can find the MAC address. We know the IP MAC address. Similarly, we can find the IP address. So duplicate address detection is done. So address is resolved. So it will be found using ARP in IPv4, but here it is ICMPv6. In IPv4, you will find ICMPv4, but here it is ICMP, Internet Control Messaging Protocol. So it has different messages. Through these messages, we can identify. So address will be resolved. If then IPv6 data will be forward. If duplicate address is found out, it will be dropped. So address resolution, as I said, this is GUA, that is done manual using Slack network discovery protocol. A stateful address auto configuration like DSCPv6, that could be done, or we can do using LLA. LLA means local link address, that is manual configuration that can be generated by the system, dynamically generated using UI64. So now we need to understand this. If we'll understand this this flow diagram, we'll able to find out how the IP address is allocated and how it is prevented from DAD, duplicate address. So address auto configuration, how it is done. Host send a router solicitation. A PC send a router solicitation in the network that any router is available in the network to the nearby host. If router is available, it will send router acknowledgement, that is RS, that signal will be sent. If the response is yes, so with Slack, the IP addresses will be generated. IP addresses will be generated. So host will generate global unique IP addresses, and it will test uniqueness of this neighbor solicitation. Means the IP address is allotted to a router, server, whatever may be. But after allocation, it will also check that there is any other IP addresses with this name. If not, if response is no, the host assigned to a global IP addresses. Then only it will assign the IP addresses of the devices. Neither, you can see this flow diagram, it will be halted. If there is any duplicate found in the network, definitely it will be halted there itself, and that process will be repeated. So I said the business drivers for IPv6. Why we want to go for IPv6? It is the need of the hour, as I said earlier also. So one and other day we have to be converted to the IPv6. Government of India has already notified, and even American government agency has said already that 2025 onwards there will be no IPv4, will be IPv6. Means other country has to follow. So we are also following, we are migrating from IPv6 to IPv4. But what happened initially, the network cannot be built in a day. Similarly, this all devices cannot be transferred from IPv4 to IPv6. What we are doing is, at the first stage, we are keeping IPv4 and IPv6 in dual mode. So wherever IPv4 network is available, will using IPv4, or wherever IPv6 it is used in dual mode. So the business driver of IPv6, as I said, one is IPv4 address exhaustion. It is written on the wall that future is IPv6 only. IPv4 is not going to support. It has only 4.3 million addresses. Our world population is 7.5 millions. As it is said, 2025, the 35 million devices has to be connected. So there is no question of IPv4. We have to go for IPv6 only. So availability of IPv6 addressing secure business continuity. So you may be comfortable at present, but in future you have to plan to migrate from IPv4 to IPv6. There is no way out left now. So IPv4 is fastly depleting. IPv6 is only long-term solution once IPv4 is depleted. That government has already said we have exhausted all the IP addresses in 2011 only. Whose company having, kindly use it, but new IP addresses will not be allotted. Only you will be allotted IPv6. Even the IPv6, the agency, that is one is NICSI, that is doing it, the IPv6 allotment part. And some schemes is also there. If you will ask for IPv4, you have to pay more. IPv6 may be free, could be allotted to you. So government mandate to implement and adopt IPv6 in the public domain. It has to be. So coming to the next business adoption, one is define business needs and objective. One is adoption of new technology. So if any new technology comes, we have to migrate as per our requirement. So IPv6 deployment and application. This organization core mission area, business needs and aesthetic objectivity is there. In the deployment, we have to see where we have to deploy first. First, core mission driven, bottom up, operationally drive. How to this is deployed IPv6. What should be our planning and the application. So coming to the IPv6 deployment, first is address plan. Your network is to be planned. What are the IP addresses required for our devices? That is to be planned. And how this IPv6 addresses will be acquired. I said in the initial slide also that this 5 RIR for India, we come under APNIC. So we have to apply for not directly to the ethnic. Our Indian agency NICSI is there, which gives the IPv6 addresses. So as per requirement, IP addresses is to be acquired using ARIN, RIPE for Europe, APNIC, LACNIC, and AFRINIC, that is for Africa. So establish address management and allocation process, and DNS also is to be changed. In IPv4 we have DNS v4 version, but will IPv6 we have DNS v6. DNS IPv4 have A records, and you will find in IPv6 is quad A record, that is there. That is future upgrades, plan for future upgrades to IPv6 capable DNS. So DSCP v6, as I said, that is to be done. That is done using that is used for dynamic allocation of IP addresses, and DSCP v6 have quadri records. So network management will be including dependency on IPv4 transport services, ability to IPv6 neighbors discovery to perform networks mapping features. So IPv6 network service deployment, how could be done if we have a network? So we should have some plan. So how our network is to be translated, is to be migrated to IPv6. For that, first thing is we require planning, application testing, that is what is prototyping. That's we are thinking of making a prototype, and training. These three are the vital for changing from one domain to another domain. If you go to the another domain, there is a challenge of security also. IPv6 security issues were different, and IPv6 security issues are quite different. If we'll have more application, so application based the security will also be there. The denial of services you will be finding man in the middle, the phishing, everything that also you have to think of. You have to think of filter rug tunnel for the firewall and routers, that also you have to plan. So IPv6 deployment or transition, one is budget cycle. Main constraint is the budget. How much portion you want to translate from IPv4 to IPv6 in dual mode? How much you have planning that to convert from dual mode to a single mode? So technology refresh cycle, IT infrastructure quality improvement, equipment and software certification cycles, IT project dependency. This parameter is to be considered while deployment of from IPv4 to IPv6. So phases of transition, as we know, one is the preparation, another one is the transition, and post transition. One it is transit, it is changed from one domain to another domain. We have to check it. Our equipment is to be extensively checked. Our this functionality is to be checked. That is preparation, that is pilot test, IPv6 network transition, and post transition is must offer IPv6 based internet services to the customers. So security plan, there will be a different security in IPv4 and IPv6. That part we have to also address. That is ACL. We know access control list in the router. We used to put some IP addresses. If a packet comes from so and so IP addresses, you have to block. That is called access list. And enable IPv6. This is detection and prevention system, intruder detection and prevention system feature, IPv6 host firewall and other end devices. But one advantage of IPv6 is it itself is a secure, having IPsec inbuilt in IPv6. So security plan that we have to see while implementing from IPv6 to IPv4. The transition, how it will be transited from one to other, I said earlier, one is dual stack. Huh? But one is dual stack, you have IPv4 and IPv6, where we have IPv4 connection, your packet will flow with IPv4. Neither IPv6, if you have in packets IPv6, it will go via IPv6. So you will have a dual networks, IPv4 and IPv6, but it is costly. One and other day we have to disable the IPv4 once IPv6 is totally implemented. So it allow IPv4 and IPv6 to coexist in dual stack. In dual stack, both have to be coexist. But in tunneling, it allow IPv6 host to communicate over IPv4 infrastructure. Tunneling is a concept. Even we are using in the lease line also. That is, one is gold plan, silver plan, or best effort plan. Gold plan is something, tunneling is like that, subscriber A is sending data to subscriber B. So a pipe, a tunnel will be created from A to B. Host will not be aware of what you are sending from source A to destination. That is the higher priority goal. Silver, even ISP able to find out if any problem is there, they will be able to identify. But in the gold, they will not be able to identify. They say my link is okay. You are sending what data that is not known to me, and best effort. This is tunnel broker. So it is by using tunneling also we can say. And transition mechanism, that is IPv4 over IPv6, 4 and 6 conversion, that we can use it. So it allows IPv4 only devices to communicate with IPv4 only. Next, transition security, as I said, if will be migrated to other domain, yeah, there we will have different challenges, and the protection system you have to implement. So IPv6, the security what we have studied up to IPv6 protocol, the transition solution, IPv6 deployment, we have seen it. But security area is the area of concern. Security may be a system may be network security, a application security, training and experiences, and hackers. As we know, hackers are very much smart. If the new application comes, they are well aware of, and they know how to crack that, and system could be attacked. So this is the famous, this is OSI layer. As we know, that is application, presentation, session, transport network, data link layer, and physical layer. And each layer have their own challenges. It is a 7-layer protocol. One is DNS, domain name service, dynamic host control protocol, hypertext transfer protocol, file transfer protocol, IMAP. LDAP is nothing but lightweight directory access protocol, network time protocol. Radius, the work of Radius protocol is AAA, that is authentication, authorization, and accounting. That is very famous protocol that is used in automatic billing systems. Wherever in the server we have a Radius server, it will calculate from the data and bill will be produced. SSH, SMTP, simple mail transfer protocol, simple network management protocol. Network management protocol is a very important feature nowadays, that is sit on the top of the network and manage. Telnet, remote logging, and TFTP. TFTP is trivial file transfer protocol. So you will find in the different layers, different protocols are there, and all protocols have a challenges. They could be attacked. That part also we have to take care of. That in the different session we can discuss this IPv6 security. It's a big, even a certification also it is there, IPv6 security certification. That is one course is already there. So ARP, spoofing, MAC flooding, and that is there. So this slide will give you the clear picture of IPv6 vulnerability surfaces. So it is given in the red is the new, and this is yellow. You can find like application attacks, fragment attacks, IPv4 threat, routing threats. These were already available in the IPv4. But threat management, if you have more facility means more risk is there. So there are risks also, that also we have to take care of. So as I said, in the security, it have ESP, that is encapsulated security payload, that is there, and that is authentication header, and IPsec security policy is there, and that goes to IKE1, the Internet Key Exchange. It has two version. We'll be looking in the next slide. IKE1 and IKE2. IKE1 is not we are using nowadays. We are using IKE2 version. So these are the IP security protocols. This is IPsec. IPsec core protocol is AH and ESP. and these are the supporting component of AHs: encryption, hashing, algorithm, security policies, security association. That is there. That is IKE. This is Internet Key Information Exchange. So Internet Key Exchange, it have a ISA KMP. There is ISA KMP. Whole specification is given in RFC 2408. Oakley, Oakley using Diffie-Hellman, who's have studies crypto technology. In that, Diffie-Hellman is there. So that all specification is given in 2412. So ISA camp is the Internet Security Association and Key Management Protocol. And another one is IKE, that I said, Internet Key Exchange. That have a version 1 and version 2 also. Version 2 is now it is promptly used. So IKE1 is dropped now. So DUI is domain of interpretation, authentication header, encapsulation, security, and payload. So ISA camp and Oakley, as I said, ISA camp, Oakley, I said Oakley protocol uses a hybrid Diffie-Hellman technique to establish session key. So Oakley uses Diffie-Hellman. It's itself is a very good topic to study. Whoever is studying security concept or cryptography, in that Diffie-Hellman is there. Diffie-Hellman is there. So this is the combination of security association. As we can see, the how data, this is from one host to the local internet. It goes to the security gateway. After checking to the security gateway, it will be given to the other security gateway, and it will be transmitted to the host. Means one host and another host, that is to be communicated. There is a core network. In that core network, security gateways are already in place. So it will be checking that the traffic, the packets which are coming, IPv4 or IPv6 is compliance or not. Accordingly, it will be passed. So, and the advantage, I say, nowadays we use IKv2 security only. IKv2 can easily be resist network changes due to mobile support. Is a very important concept concept in the IPv6. So advantage, disadvantage is also there. So IKv2 only uses UDP port 500, a firewall or network administration. So we'll coming to the VPN in private network. As I said, there are hello. There are two private networks, private network 1 and private network 2, that could be connected using security policy database or security association database ipsec engine, and could be connected using IKE engines. As I said, IKE2 could be connected. So now coming to the important discussion that we have to discuss is prototyping and validation. How the prototyping in case of IPv6 we can have the implement policy, how we can do it. So as I said, the validations are as a three-step process. One step is build and prepare. Second is test and document, and third one is analyze and decide. It has a three steps, and for each phase a typical task are outlined. As I said, just as I said, in the phase 1, phase 2, and phase 3, following task is to be performed. If it is a build and prepare phase, the definition of validation hypothesis, that is prototype development, the prototype what we have developed, that is to be test, design it to be test, and test user acquisition. And another one is test document and test document. These are the process is to be done rigorously to make it successful. And another one is analyze and decide. In that, summary, communication of the test result, preparation of the post validation phase is also done. So process design and development. process design and development prototyping. It has a 6 phase. It is to be remembered. That is, one is ideation phase. The idea is to be formulated. It is to be concrete, and concept is to be formed. Then design is to be prepared. Once design is prepared, then the engineering process is thought of. A prototype is prepared, and it is rigorously tested. As we have seen in our BTEC and other, we have a breadboard. In the breadboard, we are creating this oscillator, amplifier, op amplifier. We are connecting resistor, inductors, transistors, giving the supply that we are that it is giving faithful result or not. In the prototyping, the same thing is done. Our product is to be rigorously tested. In case of prototype, once it is successful, it will be sent to the to industry for the protection production, what I say. So it has a 6 important phases. So ideation is basically, it defines the need or opportunity to be proposed solution, and the concept part is the clearly defined the possible solution. Design go from the sketches to non-functional prototype. So as I said, this is ideation, concept, design, engineering, develop the product and make sure it works, prototyping and production. So ideation phase, I said, next is concept phase, design phase, and engineering phase, and prototyping phase. So prototype, if you'll say, the development process ends where the product life cycle begins. So at this point, we have a economic and marketing plan, how the product is to be sold in the market. That will ensure the product launch success, and that we can see in this graph. Product phase, it is given, that is introduction, growth, maturity. If any decline is there, that is over the time, that is also to be studied. So iterative process means the product development is an iterative process. If anything goes wrong, we have to correct it. And those our policy planning uh, means the version we know now, version 1, version 2, version 3, version 4. Software, it is always it is there. So it is a iterative. If anything is added, anything is modified, the version is to be changed. So prototyping, if we'll say, we can define as a type of development in which emphasis is placed on developing a prototype early in the development process. That is a prototype, and important of prototype is already given, that is validate the design, present to the investor. If once prototype is ready, means you can say, you can validate the product, present to the investor or licenses. Means you will say that I have designed a product, the prototype is this, input is this, output is this. You can ask for licensing, protect the intellectual property. You can just file for the patent. You can remove kinks in the manufacturing, test, refine, and the final product is to be given. So qualities of good prototype is, one is representation, precision, function, and improvising. So the prototype you should always scope of improvising your product based on the feedback, based on the your experiences. So type of prototype, that is based on what they present is functional prototype and display prototype or miniature prototype. There are throwaway prototypes and evolutionary prototype. As example, we can see paper prototype, a block by block a design is prepared. Here a 3D, if we want to visualize a product, we have to go for the 3D printer and we can visualize the product and we can test it. This is digital prototype, and we can find out examples of scale modeling. And the method of prototype is also two types, that is low fidelity and high fidelity, and both have their pros and cons. of this. The pros of low fidelity: it is quick, inexpensive, possible to make instant changes. Cons: an inherent lack of realism, it is there. So high fidelity, it has also pros and cons. We can see it. Guidelines for prototyping: just start building. Don't expect too much time on the prototyping. Remember what you are testing. Build with the users keeping in the mind. So the main thing is prototype validation and converting prototype to a startup in IPv6. How we can, this process could be done in IPv6. So IPv6, we can have a startup in IPv6. We can place a prototype network. We can test IPv4, IPv6, as I say, dual network transition, transport, that could be done. So that is innovation cycle and product development phases. One important thing is POC, that is proof of concept, to prototype development. Second one is significant minimum valuable product MVP and critical success factor for a startup, that is also there. So prototype validation and converting prototype to a startup in IPv6, we can review the need for innovation, process of innovation, impact, and driver for innovation. The product development cycle, as I said earlier, that is phases of feasibility, conceptualization, energy, design, manufacturing, pilots, and the volume production that we can see. These are the references of my talk to you. So I can say thank you very much. But one more thing that is not included in this slide, I will take 1 minute for all of you. Just a minute. Okay. Noise. So, okay, thank you very much. If you have any questions, earlier I said that I will be explaining you about NIXI IPv6. NIXI have a IPv6 course that is free to all the engineers. They can just log in. There are 24 modules in IPv6, and that 24 module is luckily or unluckily is delivered by us only, myself only. A student has to log in, register. They have to go through those PPT, that is lectures. They have to write examinations, and government of India will give the IPv6 certification also. Okay, thank you very much.
Okay. Thank you, Professor Ajay Kumar.
Thank you very much, sir. Yeah.
I would like to request all the stakeholders, if there is any question, please ask.
Yeah. If you want, I can this. Why? Because it was a bit lengthy PPTs also. So something somewhere some it is missed. If required, I will share to the all students. But I request to go to this NIXI site, and you can just go through those things, and you can go through these courses, and certification could be done for all of those things. Okay, please.
If there is any question, please ask.
I am stop. No issue.
Okay, sir, you can stop your presentation. Share. Okay.
Thank you very much. So I hope all of you might have understood the basic concepts of IPv6. IPv6 is written on the wall. IPv4, it has to be transferred to the IPv4 to IPv6 in coming days. India has already transferred around more than 50%. Our network is working. In fact, 60% network is working in IPv6. The main driver for IPv6 is Geo. Geo is giving only IPv6 IP addresses, no IPv4. But in case of others, if you go to the BSNL and other, you can find IPv4 and IPv6 both in dual mode you can find it. So so IPv6 is the future. That's my presentation, the aim to just to brief you. Thank you.
Okay.
Thank you very much.
Thank you, Professor Kumar, for your beautiful and elaborate
Yeah.
lecture on Internet Protocol version 6. And I think in near future, the demand of the information traffic will be so high that only the Internet Protocol version 6 can provide the needful solution. So now I would like to hand over the session our President, Institution Innovation Council of Brunei University, Dr. Sanjay Shah, for vote of thanks. Please, sir.
Good evening, and thank you, Mr. Kumar, for your highly informative information where you have talked about the evolution of IPv4 to IPv6 and need of the whole thing, security issue, deployment issue, transformation issue, and also how the government is also supporting and encouraging for this particular network. You have also talked about the prototype issues, and also you have given a chance to our budding engineers how they can think about new businesses with this type of new evolution in the network itself. So they can easily think about some startup and they will get some angel firms and investors to solve their financial problem. Sir, on behalf of the IIC Brainware University, it's a really a provoking thought which I have heard from you. And being
Thank you very
a
much.
professor of management, also I have come to know a lot about something related to internet. We are just using internet, network,
Yeah.
mobile, all these things, but hardly we are aware how it is actually functioning. The biggest problem we are having cyber security, and I think your network which you have proposed that will also solve the issue. With all these things, I would like to thank you on behalf of IIC Brainware University, and I would like to also thank you, HOD of the ECE department and his team, for arranging such a beautiful workshop cum seminar for our
Thank
students,
you.
and
Thank you very much.
definitely they will get some new light in their life. With this, once again, thanking you, sir. And this is the beginning of our journey, not the end. Thank you.
It's a pleasure for me. If any other session related to why, because as I said, if you go to the Nexus side, IPv6 advanced, it has a 24 module. All this 24 module is delivered by me only. Government of India has uploaded this 24 module to their own sites, and if students, if they are going to that sites, if they will read and write the examination online, the certification will be given. So,
Definitely, sir. I think HOD sir
yeah,
has
yeah.
noted all your points, and he will do
Okay.
the needful as per the university rules and regulations, sir.
Okay, thank you. Thank you very
Thank you.
much. Nice.
Thank,
Bye.
thank you, sir.
Okay. Thank you,
Leaving.
all of you. Then we can leave.
Then.
Pankaj, stop the recording.